Madhu sir?
Hello.
Yes, sir. Sir, shall we start, sir?
Okay, sir.
Okay, thank you, sir.
Is my screen visible, sir?
Yes, sir. Visible, sir.
Okay. So let's get into practical stuff. So we have discussed a lot of things around theory. So it's a time to jump into practicals, how to use Python, how to get the data, how to build various use cases around it. So let's talk. So the most important platform as of now for today's use case is ThinkSpeak. Okay. So let me give you a brief outline.
Madhu sir, your voice is not audible, sir. Yes, sir. Yes, sir. Now it is okay, sir.
So when you look at IoT cloud, so IoT cloud, when you post some data into it, so you can access it from anywhere at any point of time, something like Google Drive. So if you are not new to IoT cloud, just think about Google Drive. So Google Drive is nothing but a place where you can access your files, right? So if you want to share an image or if you want to share a document, so if you put it in your Google Drive, if you share your settings, okay, if you share it to public, so anyone can access with the link, or if you share it with someone else, say through email ID and all, so only respective people can able to see, right? So here also in ThinkSpeak IoT Cloud, you have that flexibility of sharing data to public. You have a flexibility to share your data with only few authenticated people. So you have all those settings here also. So here when you look into IoT Cloud, what is most important is like, you need a database server, right? Database server. What is database server? So database server is nothing but a place where you can store your sensory data. It's not about a file document, right? So when you look into Google Drive, it's all about storing images. It's all about storing documents and all, right? So here in IoT Cloud, the most important point is not about storing data in terms of files, storing data in a database server. Because when you look into sensory data, or when you look into the communication between the devices, so most of the data will be of string data type, or will be of integer data type, or it will be of floating point data type and all. So this is the kind of data type that comes from the sensory devices, right? So it's not about a file uploading here, it's about data uploading here. So it's about a sensory data uploading into the cloud. So you need a database server to store the data. So when you talk about security front, when you encrypt your data, so before transmitting on the air, if you encrypt your data, then obviously, so today, there are various AES algorithms available, advanced encryption standard algorithms are available. So there are crypto libraries also available with Python. So you can easily encrypt your data. So when you easily encrypt your data, so when you post it onto the, onto the cloud through some air or something like that, then obviously your data will be secured enough, and that data can be stored in the database server, and that data can be easily visualized. So data visualization and data analysis is very important. So ThinkSpeak is giving you that kind of flexibility in analyzing the data, because not every cloud is doing that. because ThinkSpeak is from MathWorks Foundation. So hope you're aware of MathWorks Foundation. So they have a product called MATLAB. So in MATLAB, in various colleges and universities, hope you're using it in a regular basis, right? So if you look at to MATLAB, you'll have various kinds of toolkits. So you have a toolkit for ThinkSpeak also. So when you have that kind of toolkit available with MATLAB, then you can able to run machine learning algorithms on your MATLAB, so that that MATLAB toolkit will be connected with your ThinkSpeak account through some API. You can easily analyze your data that is wrapped up in the ThinkSpeak IoT cloud. So you have that kind of integration, right? So when you look into Google Drive, you cannot have that kind of integration. So for me, IoT cloud should have a feasibility for storing data in the database server. So because when you jump into real-time scenario, people don't trust ThinkSpeak, because ThinkSpeak is a third-party cloud. Say last time I used to work on a client, so they say that they need their own server, they don't need any other third-party server. Then what we have to do? We have to build from scratch. We have to build a database server on their platform, and we wanted to build some visualization plugins on their platform. We wanted to do customize the analytic tools on their platform. So all these things we have to do it on their platform only when people doesn't trust third-party entities. So here for in research and in prototyping stage, you can rely on ThinkSpeak, because ThinkSpeak is very good enough, and it is also free up to some extent. So you can create up to 5 channels on ThinkSpeak. In ThinkSpeak, you can have all this visualizations and analysis. So that is why as this audience is also from faculty background, so I recommend using ThinkSpeak, because you have a MATLAB license and all. So you can easily integrate all your analysis or algorithms onto the ThinkSpeak data here. So if you want to understand ThinkSpeak, it's very simple. So it is also mentioned in the image, which is taken from ThinkSpeak, which is like React. React is nothing but analyzing the data. So once the data is analyzed, it has to react, right? So we have a React mechanism on the ThinkSpeak IoT cloud. And also we have API. You can easily integrate API, because we have Think HTTP service available on ThinkSpeak. So let me quickly show you all these things. Okay. So before we get into ThinkSpeak.com, so ThinkSpeak.com, you can create an account. So if you want to create an account in ThinkSpeak, make sure that you have account in MathWorks, because MathWorks is a login, is the ThinkSpeak login. So when you jump into the dictionary part of things, so dictionary is like, a channel will be there. So you have some terminologies here, which is called channel. So what is channel? Channel is nothing but a project. So where your sensory data is stored, okay, where your sensory data is allocated to it. So if you want to allocate, so if you want to, access your sensory data, you need something, right? You need an API, you need an application programming interface, right? Without that API, you cannot access, right? So everyone can be, can use ThinkSpeak, and every project will be having a respective channel, so that, you can store your data privately. And a field, what do you field? Field is nothing but a sensor. So in ThinkSpeak, I'll show you. In ThinkSpeak, you can access one channel for about 8 sensors. So which means that 8 sensors can be easily accommodated in the ThinkSpeak channel. API, obviously you need an API. So today I'll show you that also. React, so React, it all based on the application context, right? So sometimes people use time control, sometimes people use manual control, sometimes people use MATLAB analysis. So it all based on the context of the user and also application here. So let me jump into ThinkSpeak. Okay. So let me share my screen again. Let me open that. So where is this? So is this website visible? ThinkSpeak.com.
Yes, sir. Visual, sir.
Okay. So ThinkSpeak for IoT projects. So the name itself says, so it is mainly used for IoT based applications. So you can easily understand when you look at this image. So in this image, so the data is plotted. So any doubt?
No, sir. I hope by mistake they raised the hand, sir.
Okay, okay. So when you look at this image, you can able to see the graphs plotted. So they are the graphs plotted based on the MATLAB analysis or based on the MATLAB visualizations, or you can say primarily, data visualization support is available on the ThinkSpeak IoT cloud. That is also one reason. The second reason is that you can also integrate with MATLAB. So that is why people are using it. So here you have commercial use. Say if you want to use it for production, you can take, you can purchase a license from them. If not, you can use it for free also. So it is free for education purposes and learning purposes. So let me click on get started for free. So let me click on that. So when you click on get started for free, so they will be asking you to give some email ID, which is a MathWorks email ID. So if you have account in MathWorks, you can easily log in into this platform. If you don't have account, you can create it. So creation, it will take only a couple of minutes. So I'm having MathWorks account. I'll be logging in into it. So my MathWorks email ID is this, like parvathaninimodhu@gmail.com. And let me click on next. So when you click on next, it will ask password. So I'll enter my password. So when if you don't have this account, you can create it. So that will take only a couple of minutes, but they'll send you email verification. So they'll verify your email ID. So that's it. It is taking a long time. So meanwhile, let me show you the raspberrypi.org website. Okay. So this is the raspberrypi.org website. So raspberrypi.org. So in software, you will have the software related to the Raspberry Pi. Okay, so you have Raspberry Pi operating system here. So this is the Raspberry Pi imager. So what you have to do is you have to download it. So right away my operating system is Ubuntu. So that is why it is showing Ubuntu here. Or you can use this command to install the Raspberry Pi OS. Okay, so you can download this. So by using this Raspberry Pi imager, you can quickly boot your operating system into the SD card, and then you have to mount it. Okay, so you can easily see here. So you have Raspberry Pi board here, and keyboard and mouse are connected to it, and a screen is also connected to Raspberry Pi board. So thereby you can easily see this, right? So in software you'll have all this. If you want to purchase some platform, say if you want to purchase the personal computer kit, you'll have this Raspberry Pi 400 here. A Raspberry Pi compute module is also available. So this is mainly used in vision analytics. Okay, so this is Raspberry Pi compute module. So in deep learning or in vision processing, say, then this compute module will help you out. This is Raspberry Pi 4 model B. So as we have discussed, so it is also giving some desktop unit, which is like a all-in-one kit. Okay, so or else if you want to purchase Raspberry Pi 3 or Raspberry Pi 2, so Raspberry Pi 1, Raspberry Pi 0, so all these are available here. You can quickly go through that. So this is heatsink. So some of you are talking about your Raspberry Pi is getting heated, right? So these are the heat sinks, and a cooling fan is also available. If you search in Amazon, you will get all these things. Okay, so Raspberry Pi high quality camera, Raspberry Pi hat. This is Raspberry Pi camera. So this is no IR camera here. So this is Raspberry Pi hat, which comes with the cooling fan and all. So all these things are available here. Okay, you can quickly go through that. So if you want to get the beginner's guide also, you can go through this. So Okay, so these are the various peripherals that can be easily interfaced with Raspberry Pi. So for quick documentation, you can also go through this. The documentation page will be available here. Okay, so something like, if you want to start a coding club, all this free training courses, how to start Raspberry Pi. So here, how to start your database server, everything will be here. Okay. If you want to start programming with Python, so here you have a free course also. Encryption and cryptography, this is what we're talking about, right? So your data has to be encrypted enough. So you have all this, just go through this. Someone is talking about, networking. So networking is also here. Okay. This is all about sensors and all. So just go through the, all this, you can able to understand all this. Okay. Web development. So someone is talking about servers and all, right? So in the web development, you can have how to deploy your web server and everything. You can find it here. So just go to the raspberrypi.org, just click on teach. You'll get all these details. Okay. So hope it will help you out. So they're all free. You can able to, Okay. Let's jump back to ThinkSpeak. I don't know why it is taking a long time. Let me reset the page. Okay. It was logged in. So 1, 2, 3, 4. So let me delete one channel. Okay. If you want to delete a channel, generally in free, they'll give some fixed number of channels for free. Okay. So we have to delete some channel so that in channel settings, it will be there. So if you want to delete this channel, you have to select the channel and in channel settings, you can able to see delete channel. You can click OK. So this channel will be deleted. So kindly ensure that you have less number of channels so that, you can able to upload the data here. So here channel is very important because channel is nothing but an entity. It's your entity or your project where you can hold your data, okay, where you can see your data. So let's create a new channel and ThinkSpeak IoT Cloud. Am I audible? Okay, let me click on new channel. So here we have to enter some channel name. So let me enter some channel name. The first project is IoT weather monitoring system. So let me put GEC so that I can understand later. Okay, so I have to enter some name of the channel. So IoT weather monitoring system GEC, that is the name which I have given here. And description, let me write demo. Okay, I can write anything. So let me write demo. And field 1, so let me write a sensor name. Okay. Say if you have 2 sensors, so you need 2 fields. If you have 3 sensors, you need 3 fields. If you have 5 sensors, you need 5 fields. Okay. So based on that, you have to select. So maximum number of fields are 8. So which means that one channel can accommodate only 8 sensors. If you have 16 sensors, you have to create 2 channels. Okay. That is what you have to do in ThinkSpeak. If you want to use ThinkSpeak, then the number of sensors are limited here. Okay. And the number of channels are also limited because we have a MATLAB free. This is a free license. Okay. So let me write temperature and let me select the next box. Okay. So if you have one more sensor, you have to select the box, check box here. You have to enable it. So you have humidity sensor. Okay. Say if you have third sensor, say you have a rainfall sensor, say, okay, rainfall, something like that. So you have 3 sensors, temperature, humidity, and rainfall. Okay. If you have one more sensor, again, you have to, check this box and then you have to write the respective sensor. But as of now, say we have 3 sensors. I just wanted to show you how to use all this. Okay. Let me scroll down. So if the metadata is available, you can enter this metadata here. So metadata is nothing but information about the channel. If there is anything to be specified, you can specify it here. If you have any tags, you can specify it here. If you have a project website, you can specify the project website for understanding. Okay. If you have any GitHub account, you can link your GitHub, to this channel. So elevation, so that is not required. So elevation is nothing but, elevation of the city on which your device is hosting there. So that is also not required. So if you want to, provide latitude and longitude of the device, so you can provide it here. That is also not required as of now. If there is any YouTube video explaining the project, you can provide this YouTube video URL here. So that is also not required as of now. So let me click on save channel. Okay. So when I click on save channel, your channel will be created in ThinkSpeak Cloud. And whenever you create a channel ID will be allocated. Okay. So you can able to see it here, which is 1254304, which is a channel ID. So this is a channel ID. So this channel ID is the ID associated with your channel. Whenever you create a new channel ID will be created. Okay. So by default, the channel access will be private. So which means that, no other can access your data. Only you can access your data. So when the channel access is made to public, then anyone can access your data. Okay. So here it is private by default. And here you can able to see, 3 charts, which are like, field 1 chart, field 2 chart, and field 3 chart. So why we got only 3 charts here? Because we have created 3 fields. First field is temperature. You can able to see it here on the y-axis is temperature, and x-axis is date. So on which date the data is uploaded. So that will be plotted in x-axis, and y-axis will be the temperature here. So in the second chart, you can able to see on y-axis we have humidity. In the third chart, we have a y-axis rainfall. On x-axis, you can able to see date. Okay, so these are called visualization charts. Okay, your data will be plotted here whenever you upload the data. As of now, no data is available, right? So the charts are empty, and there is a specialty in this chart. So you can integrate this charts into your website also. So you can able to see it here. You have this like this. You can easily integrate. Okay, by using iframe. You can easily integrate your chart into any website. Okay, say if your website is not say if there is any project website, or if there is any website web page where you want to show your data, then you can use this iframe. So you will have that code also here. So yeah, so this is a iframe. If you copy this iframe into your website, so you can able to see this chart plugin like this on your website also. Okay. So which means that you can share this, frame. Okay. So like this, you can able to do, if you want to, change any, scale or something like that, you can able to enter all these details here. So as of now, it is not required. So all this data, we wanted to post it here. So let me jump into public view. So this is a private view. Only, it's private, right? So only you can view the data. And public view, it is not public, right? If you want to share, say if you want to share with your colleague, then you can click on sharing. So when you click on sharing, so you can see here, share channel view with everyone. So which means that everyone can able to view your channel. Or if you want to share channel view only with following users, you have to enter your email ID, their email ID here, so that only the respective people can able to view your channel. So let us keep channel private. And API keys are very important. So what are these API keys? API key will be generated for every channel which is unique. Okay, so you will be using this API key for writing data into the cloud and also for reading data from the cloud. So which is like uploading and downloading. Uploading and downloading, we will be using this write API key and read API key. So here write API key and read API key are encrypted. Okay, so if someone else is also having this write API key, they can upload your data. Okay, they can upload data onto the ThinkSpeak IoT cloud. Then again, what you have to do, you have to generate a new write API key. So that like that, we have to put it safely. Okay, so don't share this write API key or read API key. Okay, because write API key is used to upload the data. Read API key is to download the data. So you have uploading and you have downloading also. Because if you want to, all the hardware devices are required to upload the data. Okay, say your mobile app has to download the data, then you will be using write API key and read API key. So these are the keys. Okay, so these are the keys. So they are like identity given to your channel through a programmatic way, because API is nothing but application programming interface. So these are the programmable keys where you can upload your data and where you can download your data. So, but you need a request, right? So you have a API request here. API request. So there are 4 different types of API requests, out of which 3 are very important. The first one is write a channel feed. So what is write a channel feed? So if you want to upload a data, okay, if you want to upload a data, then this API is very important. Write is nothing but uploading. Read is nothing but downloading. So only there are 2 things here. One is uploading, second one is downloading. Write a channel feed. So if you want to write a channel feed, then use this API. If you want to read a channel feed, use this API. So what is this API holding? Write API is using write API key. If you look at this API, which is 61E8. So 61E8 is a write API key. So you can able to see it here. So that is a write API key. Okay. When you look at read, okay, when you look at read, so this is holding read API key. Okay. So which is like, 2A14. So 2A14 is a read API key. So that is what I'm telling here. Every API will be holding API keys. Okay. API request is holding API key. So if you want to write data, it will be holding write API key. If you want to read data, it is holding read API key. Say, if you want to read only one respective sensor, okay, then you cannot use this, because when you use this, you'll get all the sensory data. So right away in my channel, there are 3 sensors. If you call this, what will happen? 3 sensor data will be downloaded. Say sometimes you have a case like, you wanted to read only one sensor data, then you have to use a third one. So this is like, read a channel field. So feed and field are different, right? Feed is nothing but all sensors data. Field is nothing but respective sensor. So in this API request, you will have, this term, which is called, 1.json. So if you write 1.json, what happens is you will get data related to field 1. If you put 2.json, you will get the data related to field 2. If you put 3.json, you will get the data related to 3. If you put 4.json, you will get the data related to 4. So based on the requirement, you have to use this. Okay. So if you want to get updates from the channel related to the channel, then you have to use this. So this is not important so much, but these 3 are important. Okay. So one is like, uploading data, and the remaining 2 are downloading data. So when you're downloading data, if you want entire feed, you can use second one. If you want only respective sensor, then you have to use third one here. Okay. So let me upload the data first, because without uploading, you cannot download it, right? So let me copy the API request. Always what you have to do is you have to copy the API request. So you have to copy this. Okay. So you have to copy till the last. So up to 0. So what is this API request holding? So let us observe that. Okay. https:/api.thingspeak.com/update ? Update ? API _ key equal to some API key & field 1 equal to 0. So what happens here? So to this API key, 0 is uploaded to what? Field 1, which means that 0 will be uploaded to field 1 of this API key. So that is what API request is holding there. So let me copy this. Okay. Let me copy this. Let me put it in the notepad. Okay. So or else let's post it in the program. Let me open the terminal. Okay. Okay, let me share this also. So, are you able to see my terminal?
Yes, sir.
Okay, thank you. So let me create a folder first. Okay. So this is Linux terminal. So Raspberry Pi will also have the same terminal. Okay, which is Linux terminal. So let me create a folder. So you can write these commands. Okay, or else hope this video is recorded YouTube live. You can go through that video also whenever you want to do. Okay. So let me create a folder first, mkdir. So make directory space GEC ATAL FDP. Okay, mkdir is nothing but make directory. GEC ATAL FDP is a folder name which I wanted to create. Let me enter into that. CD change directory GEC space ATAL FDP. Okay, as of now, ls is nothing but listing out all the files in the current directory. So as of now, the folder is empty. So I wanted to create a script to upload the data to ThinkSpeak IoT Cloud. So uploading data to ThinkSpeak IoT Cloud in Python will take just 3 minutes. So in 3 minutes, you can upload the data. Okay, and why Python is preferable? Because it can easily communicate with the database servers. So it can easily communicate because Python is a scripting language. So it can easily communicate with servers. And most important thing is like, no need to write from scratch. Everything is available in terms of libraries. If you want to do it in Arduino, say, if you want to do it in Arduino, what is a programming language there? Embedded C++ is a programming language. So you have to write from scratch. So the thing is like, it will take 50, 70 lines for uploading the data onto the ThinkSpeak IoT Cloud. But in Python, it will be done in 3 lines. So 3 lines are like, read data from sensor, upload the data, and print what is the response of the request there. So only 3 lines, only 3 steps. So your task is done. So let me create a program, sudo space. Sudo is nothing but super user do. Generally in Raspberry Pi, you will have 2 users. One user is a normal user, second one is super user. So here generally in Raspberry Pi, you will have a username called Pi. Okay. So I have replaced, I have created a new user called mad. Okay. So you can able to see it here, mad@mad. So which is like, mad is not a super user. So it is a normal user. So what is super user in Raspberry Pi? ROOT root. Root is a super user in Raspberry Pi. So here I will be creating a Python script. Okay, if I want to create a Python script, I have to take permission from super user. So that is why I used to start with sudo super user do. Okay, something like that. Nano. So what is Nano? Nano is nothing but name of the editor. So Nano is a built-in editor in Raspberry Pi. So something like Notepad in Windows. So what is Notepad in Windows? It's a default text document, right? So here also Nano is nothing but editor. So you need an editor to write program first, right? So sudo space nano. Nano space. So let's write a program which is like, upload ThinkSpeak.py. Okay. So upload -ts.py because Python. So I'm writing a Python script here. So extension is .py. Upload -ts is the name of the program. So to understand us, so I wrote upload -ts, which is upload data to ThinkSpeak. Okay. So what is the final command here? Sudo space nano space name of the file .py. Sudo is nothing but taking administrative permission. Nano is nothing but name of the Notepad editor. Okay, because I wanted to write program. So that is the editor I'm using it here. Upload -ts.py. So upload -ts.py is nothing but a name of the file. Enter, it is asking password. Let me enter my password. Okay. So this is the empty file. So this is a file which I'm creating now. I wanted to write a program to upload the data to ThinkSpeak IoT Cloud. Okay, only 3 steps: collect data, upload data, print the response. Okay, but if you want to do that, we need to. So Python is very popular because in less time you can upload. So if you want to write a program in Arduino, so you need at least 15-20 minutes to upload the data. But here, less time, more comfort. So here, let me import the packages. Okay, so we need some packages here. So Python is popular because of those libraries, because you have extensive libraries for Python, because Python is almost 30 years old. It's almost 30 years old. It is equal to my age, which is almost 30 years old, which means that when the programming language is very old, it means that you will have extensive community support and extensive library support. Okay, so Arduino is not 30 years old. Arduino is just 10, 11, 12 years old. But Python is very old. So you will have extensive libraries for various kinds of applications related to the use cases here. So using Python, you can develop games. Using Python, you can do image processing. Using Python, you can do machine learning model analysis. So using Python, you can create web servers. So in Python, using Python in YouTube, in Facebook, in Instagram, in many places, people have used Python, for various kind of applications there. So I'm using the same Python programming language to upload the data. It's very simple. So let me do it in stepwise so that you can understand better. So step 1, so I always do in steps so that the beginner can easily understand. Step 1, we have to import libraries. Okay, So let's import some libraries, okay, which are built in. I'm not, if any library is to be installed, I will tell you which library you have to install. So as of now, I'm using a built-in libraries, okay, for uploading the data. But the most important point, what you have to understand is Python is available in two versions. One is Python 3, second one is Python 2. Okay, Python is also open source if you want to get the documentation related to it. Oh, I guess the screen is not shared. So you can use Python. You can go to python.org. Okay, so that is a community website of Python. You can quickly go through the documentation reference if you want to refer any, a library and all. Okay, so let me import libraries. Okay, let me import libraries. So that I used to import based on the context of the application. So as of now, I will import time library. Okay, I'll import time library. So here I wanted to show you the process of connecting ThinkSpeak IoT Cloud with Raspberry Pi. So I'm not interested in how to read data from sensors and all, because reading data from sensors will be different from sensor to sensor. So always reading data is same, it's not same. Okay, so it varies from sensor to sensor, because some sensors are analog, you cannot connect with Raspberry Pi directly. So you have to use Arduino, right? Isn't it? So I'm having Arduino board right away with me. Okay. So I will do data collection with Arduino. I'll do that later. Okay. So let me have some data. Okay. Step 2 is data collection. What is time library here? Time library is a built-in library to generate some time delay. Okay. Step 2 is data collection. So I have to read data from sensors. Okay. First, what I'll do is I'll write static data and then I'll read data from Arduino. Okay. So let's do static data first. Okay. I'll show you both static data and also dynamic data. Okay. Let's go for static data first. So static data is like, let's take a variable called temp. So in Python, if you're good at Python, if you're familiar with Python, variables are not declared in Python, right? So no need to declare any variable in Python. You can directly assign a value to it. So temp equal to, let me assign something like 24.0. Okay. Humidity. So temperature will be in degrees centigrade generally when you read data from sensor, and humidity will be the relative humidity. It will be of percentage. So let's say 45% of humidity is available there. And so rainfall. So rainfall will be in centimeters, right? Say we have 0.01. Okay. Say for us to understand. So this is a static data. If you could upload the static data, you can upload any dynamic data also. Okay, let me show you this first and then I'll jump to the dynamic data. Okay, so we have three data elements here. One is 24.0, which is temperature. So one is humidity, relative humidity, which is 45%, and rainfall, we have 0.01 centimeters, say. Okay. So this is a data collection, static data, and also I'll use dynamic data later. Okay. So after this use case. So this, what is step 3? Step 3 is upload the data. Simple, right? You can easily understand. Import, collect data, upload data. 3 steps. But if you want to upload data, you need to import another library. So what is this time library? Time library is to create a delay. It's not easy to, it's not about uploading data. So I'm using Python 3. Okay. So the libraries are different from Python 3 to Python 2. Okay. Python 2 is no longer available from January 2020. So support for Python 2 is wide. Okay. It's not available from January 2020 as we are in December 2020. So it is no longer available. So I'm using Python 3. Okay. In Python 3, there is a library called URL. Let me import that. Import URL lib.request as you. So there is a library called URL lib.request. So what is this URL lib.request is about calling the API request. If you observe the API request, so I have copied it, right? So if you observe the API request, it is a REST API. So to call that REST API, I need this URL lib.request. Okay, so this is a built-in library if you want to call REST API. So instead of calling, instead of using that URL lib.request every time in the program, I can call it as U. Okay, U is a reference object, which is like a namespace object. Now what I have to do, I have to create a variable called cloud_API, or you can say write_API. So I have copied from ThinkSpeak website, right? So I have to paste it. So generally API is of string data type. That is why I have included in single quotation. So in Python, there is no character data type, right? So everything is string. So you include in single quotation or include in double quotation, doesn't matter. Okay, sometimes people use it in single quote, sometimes people use it in double quote, and it is also based on the value assigned to it, right? So write underscore API. So this is a API which is copied from ThinkSpeak. I have pasted it here. The only one thing is this API is holding only field 1. Okay, it is not talking about field 2. It is also not talking about field 3, isn't it? So it is holding only field 1 equal to 0. So when you have 0, you have to delete it. So why to delete 0? Because when you call this API, always 0 will be uploaded. Our target is not to upload 0. Our target is to upload temperature value. So what is the temperature value? 24.0. So this data is static first. Okay. So when it is dynamic, so it keeps changing, right, based on the environmental changes. So here, what we have to do is a small step before we go for uploading the data. A small step is there, which is called data wrapping. Okay, data wrapping has to be done. So let me do a small step, which is like 3.0. Okay, a small tiny step, which is like wrapping data. So we have to wrap the data. So write underscore API plus equal to. So what is write underscore API data type? String data type. It is included in single quotation. But what is the data type of temp? Data type of temp is a floating point data type, right? So we have to convert into string. So typecasting should be done. Plus equal to str of, so this is a typecasting conversion of one data type to another data type. Str of temp. So that data type will be, floating point data type will be converted into string data type. And we have two more fields here. Okay, this API is holding only field 1. So what we have to do is we have to bind it. Okay, so plus single quotation open and close. Ampersand is a differentiator. If you observe this API, you can easily understand that in between API key and field 1, we have ampersand here. Okay, we have ampersand here. So that is a differentiator. Okay, ampersand field 2 equal to what? Plus str of HUM. So which is like, that is an integer value. Again, we have to typecast it. But we have one more sensor, right? One more field. Single quotation. Again, ampersand. Field 3 equal to plus what? str of rainfall. So this is how you need to bind the data. Okay. So we need to wrap the data into one variable. So what is that variable? Write underscore API. So to that variable, what we did, we have appended all the data, isn't it? So we have appended temperature value, and then we have appended ampersand field 2 equal to, because to field 2 we have to upload humidity value, to field 3 we have to update rainfall. Like this, you have to append all the data. Say if you have 8 sensors, you have to append 8. Okay, so plus ampersand field 4 equal to fourth value, plus ampersand field 5 equal to, like that you have to append the data. Okay, now let me call. Okay, let me call the data. Let me upload this data, which is step 3.1. Okay, a small step. Now we have to upload data. Okay, to upload data, what we have to do is we have to call the API. Okay, by using this URL lab.request. So let me take a variable called a, any variable name, a equal to u dot URL open of write underscore API. That's it. So now what will happen? So this API will be called. So which API will be called? This API, the updated API, write underscore API will be called. So let me print the request. Okay, print of a. Okay, print of a is nothing but printing the response. Okay, so let me put some time delay. Time dot sleep of say 4. Then 4 in the sense 4 seconds. Okay, so which is a delay time. Time dot sleep of 4, which is nothing but delay of 4 seconds here. So here 1 to 3 lines, right? So one is like, we have imported modules, we have imported libraries, and then we have collected data, and then we have copied the the ThinkSpeak API, so that we have pasted it here, and then we have binded the data. So and then we have called. So this line is very important. So this is calling the REST API of ThinkSpeak, where this API is holding our sensory data. Okay, let me run this program so that you can understand. Control key, so you can able to see options here. X is nothing but exit. So control plus X. Control key plus X. So it will ask yes or no. Save the modified buffer. Yes, you have to press Y. and file name to write the same file name. No need to change the file name here. I'll press enter. So it goes back to the terminal. Now we have to run the program. Sudo space python 3 space upload -ts.py. So here, if you want to execute the program, sudo space python 3 space python 3 is an interpreter which is built in on Raspberry Pi. So Raspberry Pi Python is built in. Sudo space python 3 space upload -ts.py, enter. Then immediately you can able to see a response object. So this is a response object which of API. When you see this response object, it means that your data has been uploaded. Okay, it is uploaded to ThinkSpeak cloud. So let me jump back to ThinkSpeak and let me show you that. Okay, let me minimize this. Okay, let me click on stop sharing. Let me share my browser. Okay, so hope my browser is visible. Let me jump back to ThinkSpeak. Let me click on private view. So you can able to see here data. What is this data? You can able to see temperature is 24. That is the value which has been written in the Python script, right? So temperature is 24, uploaded on December 10th. Time is also been displayed 12:22, 30 seconds. Okay. So on field 2, you can able to see a dot which is 45. So that is the value of humidity which has been uploaded from the Python program. And field 3 is the rainfall. So when it is for having custom visualization. So this is a part that am I audible? Okay. So let me share, the terminal. Let me upload and so if you want a value, so now this data is static, right? So we have to edit the program. Sudo nano name of the file. So let me change the values. Okay. So 24 instead of 24, let me write something like 23.0. Okay, instead of 45, let me write 47, whatever. 0.01, let me write 0.03. Okay, so let me upload this data. Control X, exit, press Y, enter. Now what we have to do, we have to run the program. Sudo python 3 upload-ts.py. So immediately this data will be uploaded to cloud. So you can able to see the response object. So let me stop sharing of sharing of my ThinkSpeak account. Okay. Yes, my what happened was my browser visible. Something is happening. Am I audible? Hello? Something is happening. Hello? Am I audible?
Yes, sir. Audible, sir.
What happened? Okay. So here I have uploaded the data twice. Okay. So one with 24, one with 20. So you can able to see a line which has been drawn between the data points. So like this line graph will be plotted if you keep uploading the data. So I'll show you the dynamic, but here in the static case, so it is drawing a simple line between the data point because two entries and with temperature 23 on with 45 and 47 you can able to see it. It's very simple to upload the data. Okay, it's very simple to upload the data. It's all about calling okay, let me do it. What happened? Am I audible? Is audio screen visible to you? My screen, Arduino's window is visible to you. Can I start typing the program?
No, sir. Sir, sharing is not done, sir.
Okay, 1 second. Okay, so I'm just waiting for the unmute. Okay, so I have connected everything with Arduino. So you can able to see my Arduino window, I guess, right? So is my Arduino window is visible to you?
Yes, sir.
Okay. So let me start writing the program of Arduino. So this is Arduino program, which is void setup and void loop. So I have connected sensors. In temperature sensor, I have connected, which is analog sensor, which I have connected at A0. And in humidity sensor, I have connected at A1, which is analog. And Arduino I'm using Arduino board, which is like, it is having 6 analog lines. So int rainfall, I have connected A2. So here, let me read the data. So to read the data, sensors are input peripherals, right? So pin mode of temp, comma, input. Pin mode of humidity, comma, input, because sensors are input peripherals. Pin mode of rainfall, comma, input. So these are the input devices. Okay. And let us print serial dot. Let us print on the serial monitor. So we have to use UART communication, which is UART communication. We have a baud rate, right? So baud rate is nothing but 9600. So which is a default baud rate. So in void loop, what I'll do is I'll transmit this data to Raspberry Pi USB port. So to do that, let me start wrapping the data. Serial dot print out. So what I'll do is I'll put hash. So this is a starting. So this is the starting of the format. So I'll put in one format so that it will be easy for me to uncache the data. Serial dot print of temp. Serial dot print of comma. So comma is a differentiator here. Serial dot print of humidity, and serial dot print of comma. So this is a different comma is a differentiator. Serial dot print of rainfall. Okay, and serial dot print ln of dollar. So dollar is the end of the format. So instead of reading temp, okay. So instead of temp, what I have to do is I have to read the data from the analog sensor, right? So what I have to do is instead of temp, you have to write analog read of temp. So it reads the data from analog sensor, okay. So instead of humidity, what you have to write? Analog read of humidity. Instead of rainfall, you have to read the data from analog pin. So analog read. So if you're aware of Arduino, so you can easily understand this. So analog read. So analog read is nothing but the name itself says analog plus read, which is nothing but reading data from analog pin. So let me put some delay. So delay of say 4000, whatever. So 4000 delay is nothing but 4 seconds of delay. So if you're aware of Arduino, so you have setup and you have loop. Setup is nothing but one-time executable. So whatever you connect with Arduino, you have to specify whether they are inputs or outputs. So sensors are always input peripherals. So I have specified as input peripherals, and I'm using a baud rate of 9600. So in Raspberry Pi also I will use the same baud rate. So serial dot print of hash, which is like a starting of the format. You can put hash or you can put dollar, whatever. So analog read of temp. So reading data from temperature sensor, and differentiator is comma. So comma is a differentiator here. Analog read of humidity, again comma is a differentiator, which differentiates humidity and rainfall. And here this comma differentiates temperature and humidity here. Okay. So at the end, I'm putting dollar. So saying that the format is ended, and delay of 4000, 4 seconds of delay. So what happened for every 4 seconds? So this data will keep sending to Raspberry Pi USB port. Okay. So let me save this program. Okay, it is saved. Okay, let me click on save. So it was saved, and let me upload this program. So you have to click on tools. You have to select the board, an Arduino AVR boards, Arduino Uno. I'm using Arduino Uno. Where is this? Yes, Arduino Uno. You have to select the board, and in tools you have to select the port number also. Port number is DEV-TTY-ACM0. So this is the port number. So I have to select the port, and then I have to compile the program. If there is any mistake in the program, it will specify the mistake. Yes, there is a mistake here. So we have to close one more bracket. Okay. So let me verify the program. So it will verify the program. Once a program is verified, you can upload this program by clicking on the right arrow. So this is uploading. So it is saying permission denied. Yes. Okay. 1 second. Let me give permission for this. Sudo chmod a plus x. Okay. So whatever /dv/tty/acm0. Okay. So now let me upload. Okay, let me give RW also. Okay, so your program is uploaded. You can see done uploading here. It means that your program is uploaded. So let me open serial monitor. In serial monitor, you can able to see that the hash value, after hash, you can able to see some digital value. So this is a digital value which has been generated from Arduino. So Arduino is having 10-bit ADC. So the maximum resolution will be 1023. So minimum resolution is 0. So in between 0 to 1023, you'll get some digital value. So this is a digital value equivalent to analog voltage, which is available at the sensors. So you can able to see this digital values. Okay. So this digital values I wanted to send to Raspberry Pi. So it is, I'm just debugging it on the serial monitor. Let me close this for a while. Let me connect it to Raspberry Pi. Let me open terminal. Okay. So let me open terminal. Let me share my terminal screen, so that because now I have to read data. So let me clear all this. Okay. Let me type ls. So here let me create a program script. Sudo space nano space arduino.py. In Python, we have a package called serial, because this data is sent to the UART port. Okay, so that is why we have to use serial package, which is a built-in package in Python. So here what we have to do is we have to create an object to access a serial port. So SCR equal to whatever, SCR equal to serial dot serial of. So you have to pass the COM port number. So /dev/tty/acm0. So that is a port number. 9600 is a baud rate. That is a baud rate which is mentioned in the Arduino program. And the timeout. So timeout be 0.5 second. If there's any disturbance in the hardware, so it will try to reconnect for every 0.5 second. Okay. So if there's any problem. So as of now, there is no problem. Okay. Now let me read the data. So to read the data, what we have to do is, let me put infinite loop. Okay, so while true colon is an infinite loop. So true is nothing but always condition is true, right? So let me read the data. T equal to scr dot read line. Okay, read line, the name itself says read the entire line right from the serial port. Okay, so if T starts with, so what is the start of the frame? If you remember in Arduino, what is the start of the frame which I wrote hash, right? If T is starting with hash, then read that line. Else we don't need any data. Okay. So let me print T. Okay. So let me execute this program. Control X, Y, enter. Sudo space Python 3 space Arduino.py. Acha. Okay. So there is error. So let me before going for this logic, let me print the value of T directly. Then there is something to be understood here. So Control X, Y, sudo Python 3 Arduino.py. So there is something here which is important to understand. Okay. So here, if you see, some lines are printing empty. Okay. And some lines are holding Arduino data. If you remember, each line is starting with B, isn't it? So B is nothing but bytes data type. So here the data is encoded, okay, by the Python library. By serial library, the Python data is encoded. You cannot access that. That is why we got error, right? So that error is due to that, the Python is encoded this data into bytes format. We have to decode it first. So when you decode it, then only you can access the data. So that is why we got that error. So let me decode that data. So if you want to decode the data, sudo nano Arduino, right? We have to decode the data. So to decode the data, what we have to do is we have to write T equal to T dot decode of UTF-8. Okay, this is the encoding and decoding standard that Python 3 uses for converting bytes data type into string data type and all. Okay, let me show you the difference. You can understand it. So previously every line is started with B, right? Now you cannot see that. So now because it is decoded. Okay, now you cannot see B. You can see hash directly because now the data is decoded. Now you can access this data. Okay. Now what I'll do is I'll write a logic like, if T is started with hash, then only print the data. Okay, it is printing spaces, right? So space is not required for me. I want only a line which is started with hash. So that is why T dot starts with comes here. Okay, so if a line starts with hash, I want to print that line only. Okay, Control X, Y, enter. Let me clear the screen. Let me run the program. Now, what happens here? It will read only the line which is started with hash, isn't it? You can able to see here. But there is one, extra line because we have written in Arduino print ln. So if you remember the Arduino program, we have written print ln. What is ln? So in Java also you can able to get this, right? System.out.println. So println is nothing but one new line. So that is why we can able to get a new line in between the data entries there. Now what we have to do? We have to extract the data, right? So we have to split the data. To extract the data, I need temperature value separate, humidity value separate, rainfall value separate, so that I can easily accommodate this data into the ThingSpeak cloud. So now what I will do is I will simply split this data. But if you look at the data, comma is coming in between the data, right? So what I'll do is I'll use that comma. So I will use the differentiate. That is why I have written a differentiator there. So Arduino.py. So now what I'll do is I will split the data of T. Okay, I'll split the data of T, which is like, T equal to T dot split of comma. Okay, now the data will be splitted into pieces and pieces. Print of T, let me show you that. Okay, now the data will be splitted. See here. Now the data is splitted. If you see the last part, so what is the data there? Say $254/r/n. That is what new line, right? ln. ln refers to carriage return and /n new line. So /r and /n. So now the data is splitted into pieces and pieces. So in the first index we have one value. In the second index we have one value. In the third index we have one value. But in the first index we have hash, right? So we have to remove that hash. In the last index, we have $, which is unwanted. We have /r, which is unwanted. We have /n, which is unwanted. Now, what I'll do is I will use slicing concept. I'll remove the unwanted characters here. So let me do that. So let me take a variable called, temp. So variable called temp equal to T of 0. Okay. Humidity equal to T of 1, rainfall equal to T of 2. So this is how the indices are accessed, right? So the members of the list are accessed. So let me print temperature colon comma temp. So I wanted to print temperature value is this. Print humidity colon humidity. Print rainfall colon. So this is a dynamic data coming from sensors, right? So but this is a digital data. Okay, but in the real-time scenario we have to calibrate it. But as of now, I'm not calibrating it right away. Okay, so let me run the program. Now you can able to see temperature is #366, humidity is 312, rainfall is $311 and a new line. So that is how the data is getting printed, isn't it? Now you can access the data, right? But we have to remove the unwanted characters. There is an unwanted character hash. There is an unwanted character $ and new line, isn't it? So we have to remove this by using some slicing concept here. Okay. So first let us remove hash. If you want to remove hash, you have to understand what is the index of hash. So index of hash is nothing but 0, right? So it is in the first character position. So what we have to do is we have to slice it. So what we have to do is we have to write one colon. So when you write one colon, the hash will be removed. Okay, it starts printing from the digit. Okay, so let me show you that. So this is slicing in Python. If you're good at Python, you can easily understand that. It starts from first index, so there is no hash comes in now. So there is no hash for temperature. So if you see here, there is no hash coming for a temperature. So your temperature is fine. So some distal value is there. Humidity is also fine. So there is a problem with rainfall. So we have dollar and /r and /n. So here the point is like, in Python, you have negative indexing also. So negative index is nothing but coming from last. Okay. So you have to say if you want to transfer from last index position, you have to use negative indexing. So here what I'll do is I use that negative indexing. Okay. So for rainfall, so there is no problem with temperature as of now. Humidity, there is no issue. Rainfall, what I'll do is I'll put column. -1 is the last index, -2 is the last but one index, -3 is the last but one index, right? So I'll write -3. Let us see what will happen. So column -3, I wanted to remove the last three characters. Okay, one is dollar, one is /r, third one is /n. Okay, so let me, I have written column -3 here. Column -3 is nothing but removing the last three characters here. So Control X, Y, enter, sudo space python 3 space arduino.py. Let us see what will happen. So you can able to see, there is no dollar, there is no /r and /r because there is a new line also created here. So now everything is perfect. So we got temperature, we got humidity, and we got rainfall coming from Arduino. So which is a digital data. Now this data has to be uploaded to ThinkSpeak. So that is very simple because previously we wrote for static. So instead of that values, you can post this data, right? So let me do that. Okay, so let me have a function definition. Okay, so let me def sensor underscore read. Okay, so instead of while true colon, what I did here, sensor underscore read. So sensor underscore read, then what I'll do is I'll return. Okay, what I'll return temperature, humidity, and rainfall. Okay, what I wanted to return, temperature, humidity, and rainfall. Okay, so this is a function definition. So I will be calling this function from the main program. So we have written a program for uploading the data, right? So I'll be calling this from that program. So sensor underscore read is a definition, and we have a return object here. Okay, sensor underscore read. So let's do that. So let's open upload program. Okay, so here we have to import Arduino program. Okay, Arduino as, okay, let's write Arduino. Okay, let's talk about static data. Let's talk about dynamic data. Okay, let's remove this. Okay, let's keep it in comment. Okay, so let's talk about dynamic data. So we have to read the data, right? So now what we have to do is let's write an infinite loop first. So while true column, so we have to read the data continuously because Arduino is sending data continuously, isn't it? So here let us read the data. So temp, comma, humidity, comma, rainfall equal to sensor underscore read. So it is reading the data, isn't it? So and then we have to upload the data. So let us put it indentation, wrapping the data, good, and then uploading data, fine. So we can upload the data, print A and time.sleep of 4. So what will happen here? So your data is dynamic coming from Arduino through a function called sensor underscore read. So this function is in Arduino program, right? So here what I have to do is I have to write Arduino dot sensor underscore read. So what is Arduino dot here? Arduino is the name of the program. In that program, we have sensor underscore read. So I have written two programs, but this program is calling that program. Okay. So the function is defined in Arduino program. Okay, anyways, so we can call that. So let us execute this program. When you execute this program, that program will be executed automatically. Okay, so no need to execute Arduino program as of now. Python 3 upload ts.py. Okay, let me do one thing. Okay, so there is some mistake. Let's write k. Let's comment for a while. Okay, let's understand what it is returning there. Let's print k. Okay, so let me check what it is printing there so that So it is printing like a tuple. So this is a tuple data type. Okay, let me wrap the data manually. So let me write if k of 0, okay, temp equal to k of 0. So let me access through index, okay. Humidity equal to k of 1, and then rainfall equal to k of 2. Okay, then let me uncomment all this lines. Okay. Oh, this is correct. Okay, let's print it. Okay, let me run this. Okay, Control X, Y, enter. Okay. So it is printing none. Okay, we'll do like this. If k is not none. Okay. Or you can say k not equal to none. Okay, let's do something like this. If k not equal to none. Okay. Temp is not defined. Okay, we have to we'll do one thing. Else, if it is none, let's pass. Okay, let's say pass. Okay, so let's say continue. Continue will be better, right? Pass that. Okay. Let's do. Yep. So it is fine. So we have temperature, humidity, rainfall. So coming up from Arduino. So it has been uploaded to ThinkSpeak IoT Cloud. Okay, let me share my ThinkSpeak account. Okay, so you can able to see all this data pushing from Arduino to ThinkSpeak IoT Cloud. So meanwhile, we got some none type objects and all. Just I have written something like not equal to. So let me explain the program for a while, and then we'll slowly jump to ThinkSpeak. Okay. So what I did here is like sometime it is printing none. So none in the sense, it is not reading the data from Arduino. If it is not reading the data from Arduino, then obviously we are getting none. Why? There is some delay. As the Raspberry Pi is operating in one speed, and Arduino is operating in one speed. Sometimes it is getting none. So that is why what I did here. If k is not none, then only read data. Okay. If k is not none, then only read data. If k is none, don't do anything. Just continue. Okay, so that is the logic which I wrote here. Okay, if k is not none, then what happens here? We are accessing temperature, humidity, rainfall, and then we are just wrapping the data to the API, and then we are calling the API. So this is very easy, right? Isn't it? So we have to understand based on what Arduino is sending, right? So this logic may differ from your Arduino. Okay, so we have to check it out. But this is a common logic. Okay. Sometimes if you get none, so you have to check whether it is none or not. If it is none, we should not do anything. We have to skip the logic. So that is why to skip the logic, what is continue in Python? So continue not only in Python, in any programming language, what continue says. So continue says that don't allow the interpreter to execute the next statements. So it is skipping the iteration. So immediately it goes back to sensor underscore read. So instead of going to step 3, so it goes back to sensor underscore read. It will read the data from sensor again. So that iterates there. Okay. So let me keep executing this program. So let me show you in ThinkSpeak IoT Cloud. So that's all about the monitoring system. So all the values will be keep uploading there. Let me share my browser. Okay. So let me share my browser. Where is this? Okay, Chrome. So I hope my screen is visible. So you can able to see the graph has been changed. Okay. So it will be changing rapidly. Okay. So dynamically the values are being uploading, right? So it keeps plotting on the line graph. So there will be some bit delay. Okay. So for every 4 seconds it keep uploading the data, right? So you can able to see the dots on the line graph. Okay, on the visualization plugins. So as of now, the data is constant. Okay, so it may changes according to the environmental factors, right? So you cannot change it in a room scenario. But when you put it, because weather monitoring station where your sensor should be outside, right? So rainfall, when the sensor is inside the room, you cannot get it correctly, right? So if it is posted outside, you may get the real value. But as of now, some sample values have been collected by Arduino, and that Arduino is pushing the data to Raspberry Pi. And Raspberry Pi, we have written a simple Python script so that your data is posted to the ThingSpeak IoT cloud. So all this data you can able to see in terms of dots. So when you move your cursor to the dot, you can able to see the value also, which has been uploaded by the Raspberry Pi. So any queries here? So let me look into chat. So any doubts? So here sensors are not connected with Raspberry Pi. Okay, sensors, if they are connected with Raspberry Pi, we have to connect only digital. Okay, so we cannot connect analog sensor. That is why I took Arduino. And from Arduino, the data is posted to Raspberry Pi through USB, and we have read data by using Python script. So any doubts here? Analog signals generally in Arduino, we have 10-bit ADC, right? So 10-bit ADC, internal analog to digital converter will be there. So that is converting analog value into digital value, but we have 10-bit resolution. So when you have 10-bit resolution, so minimum voltage is 0, right? So when the voltage is getting varied from 0 to 5 volts. So in Arduino, we have 5 volts operating voltage. So when the voltage has been shifted from 0 to 5, so in the successive approximation method, so ADC uses successive approximation method where that 0 to 5 volts will be converted into a scale of 0 to 1023. So because 2 power 10 minus 1. So in successive approximation, 2 power n minus 1 is a maximum resolution value. So you'll get 0 to 1023 based on the voltage that is available at the analog pin. So now the voltage is very small. That is why you're getting a values in between 200, 250, 300, something like that. So if the value is more than 2.5, so you'll get a value more than 512. So that's how the successive approximation method is being used in converting the analog voltage into a digital value there. Arduino, you need to download Arduino from arduino.cc. So arduino.cc is a community page. You need to download this software, but it is available on my system. So that is why I have opened it directly. So you can download that Arduino software onto the Raspberry Pi, or you can download it onto the laptop also. So that flexibility is also there with Arduino. If you want to do it on your laptop, just download the Arduino software onto your laptop. Or if you don't want to do it, you can do it on Raspberry Pi also. You can download the software, but I prefer doing it on laptop, because if your Raspberry Pi RAM is very small, then obviously it will be very slow. So it will get hanged. So that is why you can do it on your laptop, upload the program, and then connect with Raspberry Pi. You can get your task done. So anything else you can discuss. So thank you for joining me in the morning sessions. So I'll be back in the afternoon at 2 o'clock with 2 other case studies. So morning, I took a lot of time in explaining all the theory. So that is why it was a bit delayed. Anyways, I'll catch up the 2 topics in the afternoon. Okay. So
Madhu sir, there are some questions, sir. Do you take up that one, or shall we go for the next?
You can ask, sir.
From Prashant sir, there is a question, sir. How the analog signals are converted to digital in Arduino?
That is what I explained. Like, I have seen the chat.
Okay, sir. Then one more is, how did you go to the editor of Arduino.
And that also explains, sir. That's I have seen the chat.
Okay, sir. Fine, sir. So, sir, we'll take a 1 hour break. So it is 1:05. So we'll be back at 2:05, sir.
Okay, sir. Thank you, sir.
Thank you,
Thanks
sir.
for inviting me, sir. I'll join by 2:05.
Okay, sir. Thank you, sir.
So thanks all the participants for bearing me, because I used to type a lot. So thank you for everyone for all your patience and support. Thank you.
Sir, one question they are saying that, do you make blogs, sir? Kindly reply, sir.
Blogs, I don't write. So that's my answer. Like, you can follow me on Madblocks Technologies YouTube channel. You will have all the tutorials there. If you want to do it something on Arduino, so you'll have all the tutorials. I used to make only video tutorials, not I don't write blogs, because in IoT I want to show because all these platforms we cannot put screenshots every time, right? So that's why I used to do only video tutorials. So you can find it on Madblocks Technologies YouTube channel.
Right.
Thank you.
Thank you, sir.
Thank you, sir.
Dear participants, so please take 1 hour break. So be back at 2:05. Thank you so much.